This is Monday, August 8th for 0342. We're about to start our last week of work for this class, and it's a pretty easy week because there's only 3 homeworks left and the final quiz. So we're going to do homework 20 on Monday, August 8th, homework 21 for Tuesday, August 9th, and homework 22 for Wednesday, August 10th. And then you get Thursday and Friday, August 11th and 12th to do quiz 4. And that's sort of the end of this class, not completely officially, but the end of working for this class. Your grade will be all done for this class, except the review for the final in the other class also counts for this grade. And that's not due till next Friday, so the 19th. So you won't know your final grade for another week after this, but at least you'll be done working in this class. And this week should be a pretty easy week. 1 assignment in each day instead of doing 2 or 3 assignments in a day. And when I was doing the last video last week on Wednesday, when I did homework 17, 18, and 19, I forgot to do the word of the day that day. So if you noticed that or are just realizing it watching this video, you can just send me an email for Wednesday. That was August 3rd, Wednesday, August 3rd. If you just say the word of the day was none that day because I forgot to do it. And then you'll get credit for that. And then I should remember today to do it. The issue is I have 4 classes that I'm making videos for, and this class, your 1324 class, and I have 2 other online classes. One's a 1325, another one's 1342. And this is the only class where the videos count as part of the grade. So if I get going in a video and I'm not paying attention to which class it is, I can forget to do it sometimes. So the word of the day today, the first letter is C as in cat. We have 5 problems here. Summation notation for homework 20. Okay, so I think we saw this in our other class already too, but at least this will reinforce it a little bit. So problem number 1, this is a Greek letter that they use in math. They actually use a lot of Greek letters in math. The most famous one is, you probably know about, is pi. Pi is a Greek letter, and in math we use that to associate with a special number that goes 3.14159. So Greek letters are commonly used in math to represent things. This one here, it looks like kind of sort of like an English letter E. This is the symbol in math that means sum of. And then in the summation notation, they call it summation notation, you put a counting number on the bottom and the top of the sum symbol. And the variable can be anything, but they often do I's, J's, and K's in the middle of the alphabet. So K equals 1, that tells you where to start at. And then the top tells you when to stop. And if you ever got to calculus someday, in calculus they'll actually go to infinity. They won't even stop. But luckily for us, we just have to do 1 through 5. So this tells us to start at 1, then go to 2, then 3, then 4, and you keep going until you hit this number 5. And this can be any expression they want to make it. Sometimes it has a K, sometimes it has more than 1 K, like here. Sometimes it doesn't have any K at all. But the K's are where you're plugging stuff in, if you do have any. So because I have K equals 1 at the bottom, that tells me that K is the variable of interest. And then if I see any K's over here, that's where I'm going to be plugging numbers in. A few of these have a shortcut, but they're very special cases. This is a generic one. This one does not have a shortcut. So literally what you do is you start with K equals 1, and you plug a 1 in everywhere you see a K. So that gives me 1 parenthesis 1 plus 5. And now it's just about doing the math, doing the order of operations that would get you this answer. I would do the parenthesis first and get 1 plus 5 is 6. And then I can do 1 times 6, and that answer is 6. Now you move to the next number 2 and stick 2's in for these 2k's. 2 times 2 plus 5. And you do the parenthesis first, so 2 plus 5 is 7. Then 7 times 2 is 14. And this symbol again means sum of. So after you get each answer, you start putting pluses between them all. So then I'm going to add whatever the answer turns out to be for 3. 3 times 3 plus 5. 3 plus 5 is 8. 8 times 3 is 24. Plus whatever I get for 4. So you wouldn't want to do this if it was too large, like from 1 to 1,000 would be really killer. But there are some shortcuts that can happen on certain problems when that does happen. And we're not going to have to worry about it. They're just giving you a short case because they just want to teach you the process first. So now stick 4's in for these 2k's. 4 times 4 plus 5 is 4 times 9, 36. And plus one last time, I'm going to stop at 5 because of that 5 up here. So put a 5 here and here, and then 5 plus 5. So it's just a coincidence that this 5 matches that 5. They don't have to match each other. But 5 times 5 plus 5 is 10. 10 times 5 is 50. So whatever these 5 bottom answers add up to, that's the final answer. Put this somewhere where you can see everything. There. Okay, so it's 6 plus 14 plus 24 plus 36 plus 50. That equals 130. The second letter today is the letter O. O is in ocean. Okay, notice they switched to J instead of K. That doesn't really matter as long as I have J's in the expression, which I do. So J equals 1 to 6, and all I have is 8J. There's just a single variable this time. The expression can basically be anything they want it to be. So we got the sum from J equals 1. Now you don't have to start at 1 either. That's the most common one, but it's not absolutely necessary. 6 and 8J. So now I'm going to have to do 6 different cases. I have to do J is 1. That's easy. 8 times 1. There's less calculating this time. The first answer is 8. Now plug in 2. 8 times 2 is 16. Now you go to 3. 8 times 3, 24. Now maybe you see a pattern after a while. These are the multiples of 8. 8, 16, 24, 32, 40, 48. You might even find that to be a shortcut. And if you didn't notice that, you could have kept going. J is 4. 8 times 4 is 32. When J is 5, 8 times 5 is 40. And if J equals 6, 8 times 6 is 48. Eight plus 16 plus 24 plus 32 plus 40 plus 48. So now the sum is 168. I'm going to give you a double letter here. The next 2 letters are both letter L. L is in light. Turn the lights on. double L. Whoops. It's weird how that popped up. Okay, so well, maybe I should have read that. It's okay, we'll try this and see. There's some kind of star here for some reason. Okay, so now we have sum k equals 1 to 3, so we only have 3 cases to do. 18 times 1/3 to the k. And there's a k at the bottom, and there's only 1 k in the expression. K equals 1 to 3. 18 times 1/3 to the k. So first we're going to plug a 1 in right there. When k is 1, we're going to get 18 times 1/3 to the first power. And you should do the exponent before you multiply. So it would be 1/3 to the first power, which is 1/3. And 18 times 1/3 is actually the same thing as 18 divided by 3. That's 6. But if you didn't know that, you could literally type 18 times 1 divided by 3. 1 divided by 3 is 1/3. So there's 6. Now do k equals 2. 18 times 1/3 squared. When you square a fraction, you do both parts. 1 squared is 1, and 3 squared is 9. So now it's really just 18 divided by 9. That answers 2. But if you didn't know that, 18 times 1 divided by 9 is 2. And finally, we only have to do this 3 times, luckily. K is 3, so now plug a 3 in here. 18 times 1/3 to the third power. So 1 to the third power means 1 times 1 times 1, but 1 times itself as many times as you want to do it is only 1. And then 3 to the third is 3 times 3 times 3. 3 times 3 is 9, times another 3 is 27. And now this does not divide evenly, but both of these numbers divide by 9. $18 divided by 9 is 2. 27 divided by 9 is 3. So now maybe that's what that instructor note, there was an instructor note that I didn't know where that popped up from, so I just closed it right away. But maybe they wanted to mention how they wanted this answer, but usually the My Math Lab tells you that. Simplify your answer. Yeah, it doesn't, maybe that's what that was about, because it doesn't say how they want the answer. But what we could do is we can put these over 1s, and we just need them to all be over 3. So multiply by 3 over 3, 3 over 3, 6 times 3, I'll get 18 over 3 for the first one, and then 6 over 3 for the second one, and the third one's already over 3, so 2 over 3. Common denominator, the denominator will be a 3. So 18 plus 6 is 24. 24 plus 2 is 26. 26 divided by 3. And we usually like these improper fractions in higher level math, so I wouldn't change it to a mixed fraction or anything like that. But if you could reduce it, you would, but 26 doesn't divide by 3 evenly, only 24 and 27 do. So I'm not sure what that, maybe let me see if I go back, if it comes up again. Here's this. Follow the definition of summation. We will not learn formulas. Okay, yeah. Okay, do not follow the help me solve this. Okay, I see what they're getting at here. So some of these, as I mentioned before, some of these do have a shortcut, but only if they're in a certain style that you might not have noticed. So it turns out if the style is linear or exponential, then there's a shortcut. And I guess if you hit help me solve this or view an example, it shows that, and that's actually taught in pre-calculus. So they don't, I guess they don't want you guys to know that yet, but they must have grabbed this problem out of it says it came from another textbook. So that's what the star is saying. Copied from a different textbook. So they must have got this out of a pre-calc book just to teach you the basics of it. But it turns out there actually is a shortcut to some of these. See, that one's exponential. This one's linear. This first one is quadratic, actually. Quadratics don't have a shortcut. So notice there's no star there. But some of these others would, and they don't want you to do the shortcut at this point. They just want you to just literally do it as is, which you have to do on, if you don't get linear or exponential, you have to do it the slow way. But it does turn out that if it's linear or exponential, there is a shortcut to it. So let me give you another letter for today. The next letter is letter E. E is an egg. Okay, number 4. K equals 1 to 5. We want the sum from K equals 1 to 5. They like 5 for some reason a lot. And our expression is just K minus 3, which is linear. So then I need to do K equals 1, K equals 2, 3, 4, and 5. First, you plug 1 in. 1 minus 3. That's the only operation to do, so there's no order of operations here. There's literally 1 minus 3. I don't need the parentheses anymore. So 1 minus 3 is negative 2. Now plug 2 in. 2 minus 3 is negative 1. Plug in 3. 3 minus 3 is 0. Plug in 4. Maybe you see a pattern already. 4 minus 3 is 1. Each time it goes up by 1. Next one should be 2. 5 minus 3 is 2. And this answer is 0. I can tell already without a calculator because negative 2 plus 2 is 0. Negative 1 plus 1 is 0. Plus 0 is 0. But if you didn't know that, negative 2 plus negative 1 plus 0 plus 1 plus 2 equals 0. Okay, we got 2 letters left. The next letter is the letter G. G is in gasoline. And we got 1 problem left and 1 letter to go. Okay, so here's a concept that if you know the summation for one particular expression, and that answer is 77, and then if you did a similar one, the same from 1 to 11 on each one of them, but you did it for another part, and that was 64, what would happen if you added the 2 expressions together? Well, it's kind of like having a polynomial where you have a bunch of terms added together. It turns out you can do them part by part, term by term. So the sum of a summation is equivalent to each summation added together. So then I don't have to take the time to go through all 11 of these. In fact, I couldn't because they would have to tell me what the equations are. But they purposely didn't tell you the equations because you're supposed to just take this 77. Somebody took the time to do all 11 of these cases and came up with an answer of 77, like we did on the first 4 problems. But that, you can replace that right here. And then same thing here, 11 calculations gave an answer of 64. So let me write out what's actually happening here. If the sum from 1 to 11 For some expression, they're just putting AI here. They don't want to tell you what AI equals. AI just means I is any number between 1 and 11. So it could be something like K